Okay, moving on. Next example, we are finding the we are finding the component form of a vector given its direction and magnitude. So there's two ways to describe a vector. Okay, you can describe a vector by giving its x and y coordinates, right? How far does it go horizontally? How far does it go vertically? You can draw that vector that way. You can also describe a vector by giving the direction with an angle measure, a degree or radian measure, and then by saying how long it is, right? So this is kind of alluding to what we're going to learn in the future, polar form. The angle and the magnitude are one way to describe a vector. So if we're given the angle and the magnitude, how do we convert that back into component form, which is what we're used to with the x and the y? Okay, so we want vector v, we want to know what's the x and what's the y. We want to fill in these blanks for this angle, this vector here. Well, let's draw it. It's at an angle, direction angle of 120 degrees. So which way is it facing? Well, this is 0, just like with the unit circle, that positive x-axis is 0. If we go 120 degrees, maybe we're like going, that's about 120 degrees right there. There's our theta. And we have a magnitude of 10, so I'm just going to kind of guesstimate that that's probably, I don't know, 10-ish. Okay, so 120 degrees, our magnitude of 10, there's vector v. What we want is the x-coordinate and the y-coordinate of this vector. Okay, so let's go ahead and draw that. I want to know what's this, the x-coordinate, what's that, the y-coordinate, and that happens to be a right triangle, yeah? Okay, if you look at this for a second, you realize we just have a right triangle. We know one of its side lengths, and we actually know one of its angles. We can find the other missing sides using SOHCAHTOA, or using our knowledge of special right triangles if you recognize that it's a special right triangle. Okay, but let's just use SOHCAHTOA because you guys are pretty good at that. Y is the vertical component. It is opposite from my angle theta here. Well, here's theta, right? Here's our reference angle that we look at. This is the reference angle that goes down to the x-axis. We treat that as our angle theta, right? Y is opposite from theta. 10 is hypotenuse, and that's the value that I know. Opposite hypotenuse. Which trig function is that? That's sine, right? So to find y, I'm going to go sine of theta, which is 120 degrees, equals opposite over hypotenuse, y over 10. Okay, that's how I'm going to find my y-coordinate. Well, I know the sine of 120. That's on my unit circle. That's positive root 3 over 2. And now I can just solve for y by multiplying both sides by 10. Okay, multiply both sides by 10. I get 10 root 3 over 2 equals y. The 10 and the 2 simplify, and we get 5 root 3 equals y. And guess where the 5 root 3 goes? That's the y-coordinate of my vector. That goes here. Okay, easy enough. We're just using SOHCAHTOA. Okay, let's do the same thing for x. Where is x in relation to my angle, 120 degrees? It's adjacent. And 10 is hypotenuse. Adjacent, hypotenuse, I'm going to be using cosine, right? And you guys might remember, sine is always the y value, right? And cosine is always the x value. So you can remember that too. So the cosine of 120 equals x over 10. And we'll solve this the same way. We just have to know what the cosine of 120 is. Hopefully you remember that it's negative 1/2, or could figure that out using a unit circle or using your understanding of the special angles, right? Multiply both sides by 10. Negative 10 over 2 equals x. Negative 5 equals x. Oh yeah, it makes sense that it's negative because x is in the negative direction, right? So there we put negative 5. So x, this value right here is negative 5. This value right here is the y-coordinate. That's 5 root 3. Hey, do you recognize the special right triangle? The hypotenuse is the short leg is half the length of the hypotenuse, 10 and 5. And then this long leg is just the short leg times root 3, right? The 1 to 2 to root 3 ratio of the 30, 60, 90. Yeah, that's a 60-degree angle. So you get your 30, 60, 90 triangle there. Okay, so there's our component form of our vector. It gives us the x and y coordinate given the angle and the magnitude of our starting vector v. Okay, moving on.